Awesome. So, welcome everyone to tonight's StudyTank session. I'm Nonso. I'm a software developer and one of the community organizers here at TechTank. Part of TechTank really is our StudyTank series, in which is an initiative that allows or brings about a virtual space to bring people together to discuss concepts around web technologies. This is not limited to data structure and algorithms, but it also includes web fundamentals and other web-related topics. We started the Community Educators program really to invite members from the community to speak about and teach about topics that they are passionate about, because we believe that the learning is not just about acquiring knowledge, but it's also about how we effectively communicate the things we learn. And so tonight we have an awesome session by Chelsea, who's really going to be talking to us all about Cypress. And at the end of the presentation, you'll get a chance to ask questions to Chelsea through either the chat or by unmuting your mic, and we can have a pleasant discussion around that. And so, without further ado, let's welcome Chelsea up to the panel here.
Thank you so much, Nanzo. I'm going to share my screen and we're just going to get going because I think I might ramble at some point. So I'm just going to fly off with this talk about Cypress. I called it Cypress for the overwhelmed developer. And I hope that you kind of felt something about the title and decided to come today, or you're just interested in learning about Cypress. My name's Chelsea, like Nansa said, and I've been a JavaScript developer for the last 6 years. I'm actually an expert in being overwhelmed, and I've worked with Cypress and really enjoyed my time using it. So I wanted to give a talk about it. I know it's not the newest or the hottest testing platform anymore, but I have really enjoyed using it. So what am I here to talk about? When you lay your head down on the pillow tonight, I want you to be able to think about like, what is Cypress? Why would you write component tests? And how could you do that with Cypress? Because you won't pick up a tool and use it from scratch. If you're like me, if you don't know a little bit about it and you don't feel like you can get your feet wet right away. So what I'm going to talk about tonight is a little bit about testing, a little bit about component testing, mostly about how we do it with Cypress, how Cypress does component testing, because it's fairly new, and just how to write those tests yourself. And then I'll show you a little demo about how to do it. So a wise man once asked these three pertinent questions about testing. What should I test? When do I test it? And how many tests are enough? And of course, that was Kent C. Dodds. And he went on to write an entire course about testing methodology. But you're here because you don't actually have time for another course, probably. And sometimes you like going outside and you just want somebody to tell you stuff about testing in Cypress. And that's totally okay. I'm going to not talk too much about Kent, but I'm actually going to tell you how he answered these questions. He said that testing is primarily there to give us confidence about how users interact with our software, and that instead of having 100% coverage, we should write tests for a large number of use cases. And if you don't know anything about testing at this point, because you work at a startup and they don't believe in testing only in production, then we'll talk a little bit about testing, and hopefully you'll pick up a few things. So this is Martin Fowler's testing pyramid, and this is how a lot of people think about unit testing. Unit tests form the foundation of the pyramid, which is why they take up the most space, because it's thought that you will write the most of these types of tests. So unit tests focus on a single isolated piece of your application, like a function, which you will have to check to see if it works like you think it does. Think of unit testing like testing a function in a black box. You give it specific inputs and you just check if it produces the expected output without worrying about how internally the function works inside. So it's a really great way to document the intention of a function. Oh, I should talk about the other types of tests. So integration tests are for making sure that different parts of your app work together properly. So unlike unit tests, which test things in isolation, integration tests focus on how different components or functions actually interact with each other. So while unit tests are independent, integration tests are exactly what they sound like. They're meant to rely on those connections between different parts of your app. So for example, you can test that any API call is made as expected, when it's expected, and that the responses are handled correctly in your UI. So however, since we're writing integration tests, sometimes we want to make sure that we're also figuring out exactly how the entire app behaves end to end. And that's where end-to-end tests come in. So end-to-end tests usually check the flow of your app from start to finish. And realistically, I think they were invented to help people sleep at night. For example, you might write a single test that registers a new account, logs in to that newly created account, purchases a product, and then logs out. And that is all one test. And that test is particularly valuable because it ensures that all the parts of your application, from the front end to the back end, work together. You can think of that as your happy path. Since end-to-end tests mirror how users interact with the app, it's really validating your app works the way it should and makes money or is usable. So integrating E2E tests into your CI pipeline makes the most sense. And that makes sure that every time someone from your team goes to add their branch to main, that they're not breaking the app. Or if they are breaking the app, they're changing how it works. They've thought about that change and they've made the correct steps to update the test and reflect those changes. So component testing is a little bit different, a little bit the same as unit and integration testing. And a lot of us here are very likely React people. So we probably dream in components and we think about our apps in terms of components, reusable, composable, nested components. So component testing is where we isolate a part of that system for testing. And this just means we're testing the UI without involving the entirety of the system. So there's no crazy setup for an end-to-end test, and we're just testing one component. But as we know, a component could have or rely on several smaller components inside of it. So while you can unit test each small component individually, it usually makes more sense to test the entire component together to make sure everything works properly. And that's a little bit more like an integration test. So Cypress itself, what is it? Cypress tests anything that runs in the context of a browser. So Cypress is designed to check if elements on your web page are visible, usable, and interactive. And it's built specifically for testing user interfaces, which makes it really great for UI developers. It was originally made only for E2E testing, so end-to-end testing, but component testing came out in about 2002, 2003, and they're different in Cypress because you can mount a component on its own instead of loading the whole app by visiting a URL in your app. So this lets you focus on testing just the component's functionality without dealing with all the extra stuff that comes with testing the full application. So when you run a test, you can see your component on the screen next to the test results. And then even after the test finishes, the component stays interactive so you can debug any issues using your browser's developer tools in the testing environment. And my last bullet on the slide is, yes, I know Playwright exists, because even though Playwright is great I haven't used it, but apparently it's very well liked. The issues are kept fairly minimal. It's maintained by Microsoft. I still really like Cypress because I think it provides a more intuitive testing experience, and its docs are really friendly for new developers. So if you're not familiar with testing libraries, I personally think that this is a great starter tool, and you can just learn more about testing and testing libraries from there. So when Cypress mounts a component, it does it in an actual browser. And you'll be able to visually see and interact with that component as you work on it. And you can use the same browser and the same browser-based developer tools that you are using to build that component, like the inspector, or being able to print the console, or being able to read the output of an HTTP request. So Cypress can therefore modify everything coming in and out of the browser. This also gives it native access to things like the window object, the document, DOM elements, and even service workers. The best thing I think about Cypress is that it will automatically wait until an element becomes visible, becomes enabled, or you can interact with it when another element is no longer covering it. And Cypress will continue to try to interact with that element until you've set a timeout or until it's no longer possible to do so. So we can also make network requests like a real user would. And when you test like a real user, there are some thoughts you need to have about how you're going to handle the buildup of state on your database if you're actually using, your actual database. But that's a deeper conversation than this lecture can go into. And I can send you a video on the topic if you would like to learn more about it. So to write our tests, we need assertions. Assertions basically check if things in your app are working the way you expect them to. So generally the format you use is a describe block, and then an if block is defined right away inside of it to define a single test case. Each if block contains the code that it will execute in the test, and then any actions or assertions or interactions will be covered under that test. So at the end, you usually compare the actual outcome to the expected result. But in Cypress, you confirm that elements exist, have the right text, or behave correctly because you're testing like a user. So how does Cypress select elements? So those assertions will help yield elements instead of returning them, which means that you can't directly assign the result of a Cypress command to a variable and have it work. If Cypress doesn't find your element, it's going to retry until it can get that element, or if you're using a timeout, till the timeout is reached. So when we go to select our elements, we want to do so in a fairly specific way. There are some best practices. This is straight from the Cypress docs. And I would say you would use them exactly like they're defined. So we want to use a data dash something attribute. It can be data dash sci. You'll often see data dash sci. It's kind of like the calling card of Cypress. And it's really great for being able to be stable because it's not going to change due to any design updates you do. If you see that data sci, you're going to keep it there and avoid naming it based on styling or appearance because you know you really want to name it and tie it to what you're testing. So generally that attributes function like data sci equals submit, and then it will be isolated from any types of changes. We also want to avoid using class names to select our elements because they're likely, again, to change with that styling update. We want to avoid selecting by text. It's fine most of the time if you're serving, just places that only use one language. But whenever you use sci.contains or any other assertion based on text, you're asking for the specific presence of that text and not general element selection. So you generally want to stick with attributes-based selectors for interactions. IDs used very sparingly, or probably not at all, because they'll be accidentally removed as it's not obvious that you're tying it to your testing. You also want to avoid overly specific selectors that target exact DOM structures because that's prone to breaking with any minor layout change. So again, just keep it based on key attributes that you need to test like a user. We also are going to talk about stubs and spies. And if you're new to testing, you'll be new to these terms, and that's really okay. We're just here to dip our toes in. So a spy is a utility function, and it's really helpful for unit and integration testing. And a spy monitors the behavior of an existing function. So let's say you have a submit function. We're just simply going to observe and record the number of times that function is called, with what arguments or what it returns, but we'll never replace or control the function's behavior with a spy. So again, you're just going to trigger that submit function when it's clicked, but you don't need to control the behavior of it. Just verify that it gets called. Stubbing is also cool. I guess this is the spies. Yeah, and this is the stubbing slide. Stubbing is also cool. Stubbing lets you control response bodies for your HTTP requests. So you can give them status codes. You can have headers without changing your server or client code, which is super fast. However, stubbed responses don't accurately match the actual data, as we know that actual data can change. So if it's not sent by the server, you can't exactly rely on it. So it may lead to some gaps in test coverage for your endpoints. If no responses are stubbed, that means your server has to actually send real responses. And this can be fairly problematic because you have to seed a database with every object that it takes to replicate the same features in your application and potentially build up state with all of your tests. So since real responses can be much slower, you may not want to use stubs, or you may want to use stubs very sparingly. And stubs are also not retryable in Cypress. Cypress retries commands like sci.get and other assertions like sci.should until they pass. But stubs don't inherently have that retry logic, so you have to handle that yourself. And now we have time for our demo, which is great. Okay. So I put together a really small demo. The first thing I did was I downloaded Cypress, so I'm not going to show you anything that granular, but I will show you how to run Cypress. So if I Control C on Cypress and I make this way bigger, Command plus, you can see that the command for opening Cypress is npx cypress open. And once I start to run Cypress, it will actually give me a window for my test runner, which is pretty sweet. It's going to ask me whether I want to do end-to-end or component testing. I'm already configured for component testing, and then it will allow me to choose a browser and start to run my tests. But we're not quite ready for that yet. So let's talk about some of the other things that Cypress is going to give us straight out of the box. So in this support folder that comes ready-made, we have different files that Cypress has given us. So command.js, you can use to add commands for automating logging in as a particular user, things of that nature. And that's also deeper than the scope of today's talk, but any commands that you create can be added here, and they give you some ideas for commands that you might need. So dragging and dropping elements is also mentioned. It's pretty cool. Once you've written your own commands, you can then go ahead and add them to component.js. So this is where we could put any particular config that we might need for our app, and that's going to run and make ahead of running our tests, those commands available. And then we have our component dash index.html. So Cypress renders your component here and only your component, not your whole app. If you're familiar with the React internals, then this should look very familiar. Don't touch this file or you're going to break your test. So from there, we can talk about fixtures. Fixtures are where you can keep track of mock data, and you can use that mock data inside of stubs as the response for a payload. This downloads folder came empty. I don't know what it does, but that's okay. We can also have our own folder. So this is a folder that I made up and added to test files 2. You can see that they both end in .sci.jsx. When you end a test in .sci.jsx, that just means that Cypress will pick it up as available to run. There's that way to make new specs for Cypress to run, so new files with tests in them. It's also called a spec. There is also another way to make tests for Cypress to run. If I pull it up here and start component testing in Chrome, you'll see my tests are going to be available, but I can also hit new spec in the corner here. And there is a GUI that lets you create a spec from a component. And then you can select any spec, or sorry, any component to turn into a spec. So it's pretty basic what it gives you, but it is faster than possibly writing it yourself, and also gives you an opinionated place about where that test should live. So if you don't want your test to live specifically next to that file, then you'll have to make them yourself. Okay. So we can already see this is what the environment looks like. I have my sign up form, and that's just like the basis of my app. So once I click on my sign up form.sci.jsx, my test already starts running, and I can see that it's failing for some reason. We'll take a look as to why it's failing, how we can write a better test, and maybe what we should be even testing for in the first place. So I'm going to put this away again. If we take a look at the app that I've created, it's fairly simple. That's a lot bigger than I thought it would be. Top right. Nice. Okay. So the app I've made is fairly simple. It's a form. The form is made with React hook forms. There's a little bit of validation on it, but we're not testing validation today. And it allows you to sign up. And when you hit sign up, it will actually hit the server that I've made, very basic server. And all the server does is send back a 200 and a message. So that's great. If you want to take a look at what it looks like, you can see the code here. So just a little bit of logic to contain its visibility for the pop-up. We have my handle sign up, and the form itself is in a different file. This is going to be a little bit important later when we talk about which components we want to test. So let's take a look at our sign up form. We know this test is failing. In fact, let's put it right next to our other test. Okay, so we can see our test is failing. We can even click on the assertion that it's failing on, and we can read more about it. It's printed out in the console, but I'm not going to open the console. I'm just going to use the explanation from the window here. I have an expectation that my input would have an attribute of placeholder with the value enter your home address, but the value was enter your name. And you may remember something that I said about how to select elements in a way that makes them more unique, easier to find for Cypress, and easier for you to remember that you're using Cypress to specifically get this input. So in my test itself, I have a describe block. It's called banking signup form component. It renders the form fields correctly. So in that if block, I'm saying what we're going to do in this test, what my test should deliver. And then the first thing we do is we mount the signup form with an on submit of an empty function. That empty function is empty because we really don't care about the on submit function. We really just care that the form fields render correctly. But the way that I'm asking for these form fields by input of type text is not stable enough for Cypress. Cypress is really fast, and it's going to see this first input. And then by the time I've gotten to my last input, it may not actually find it. So I've made my test flaky, unbeknownst to me. So let's fix these sci.gets, and we're actually going to use sci.data selectors instead. So I've already made these sci.data selectors. And so all I have to do is input them into this form, or into this test rather. So I can replace input of type text with sci dash data equals input dash name. And then you put them inside square brackets. And this first assertion should pass just fine as it did before. And I'm going to change them for everything, but I think you should also see side by side what it looks like in the page itself. So if I go into components, into form.jsx, you can see I've put that data sci attribute directly onto my input. And so I don't have to worry about the type of the input anymore. I can just refer to it by its more unique and more relevant name. Okay, I'm going to copy and paste the rest of these sci data in, just so you can see the test run green. And so that you can read the new name for each. So we have sci, data sci, input email. We have one for input password, one for input phone, and the last one is input address instead of another input of type text. Okay. So as I refresh, we should see the test run again. And I have an error. Expect SciData input name to have attribute placeholder. Input name, attribute placeholder. But never found it. Aha, I have spotted my mistake, I think. I think it's a typo. Oh yeah, okay, there we go. There's my typo. I do this regularly at work where I code in front of people. Oh, and it goes all wrong. And it's going all wrong right now. Okay, that's all right. Let's see if my demo key test does any better. And it does. Yeah, okay. It's very similar. Probably another typo, but I did validate all my tests ahead of time. Okay, so let's move on to submitting our form with the correct data. So we can make another if block right here. And we'll call this one stubbing, or rather maybe submitting. Submit the form with the correct data. We really want to describe what the form is supposed to do and what our test is supposed to describe. And then it's arrow function. And then inside of the arrow function is where our assertions will go. So the first thing that I'm going to do here, besides mounting my sign-up form, is create a stub for the forms on submit handler. So before I didn't care about the forms on submit handler, but now I actually want to check that the form submits with the correct data. So I'm going to const on submit equals sci.stub. And so when I use sci.stub in this way, without any arguments given to it, the stub is replacing the real onSubmit handler. So it's acting like a spy in this context. So it's going to track whether the function is called and with what data, but it's still a stub because I'm going to also use it to control the behavior of the onSubmit function by having it return a specific value. So I'm going to mount my sign up form again. And then I'm going to give the onSubmit this stub. Cool. So now I'm going to get all the elements and also type into the fields. And so to prevent myself from messing this part up, I'm just going to copy and paste it, which is fine. And then I also want to be able to submit the button and, or sorry, click the submit button and interact with the form in that way. So site.get single quote data dash sci equals double quote submit dash button. Forgot the double quote on the other side and the closing bracket dot click. Okay, let's see if this works so far. Again, I'm really just skimming the surface of what you can do with testing in Cypress. I'm not talking about clocks, and I'm definitely not talking about, it starts with a P, promises. Uh, there are specific things that you need to know when working with Cypress about promises, but I'm definitely not going to get into it today. I'm just going to show you how to use sci.then to wait for the form submission that I'm going to assert with that on submit. So first, I'm going to just change, again, how my function works. I'm going to take my on submit and return something that it doesn't actually return, which is like Cypress or the overwhelmed developer, right? And then I'm also going to check for that in my sci.then. So my sci.then is going to wait for my on submit to happen. I've momentarily forgotten how to do that. Okay, great. Yep. And then I'm going to expect that my on submit has been called once specifically, with some data that I've already inputted. So I can check exactly what has been called with my on submit, and then I can also expect the return to be whatever I used here. Expect on submit to have been called once with, sorry, typo. And there we go. If you want to learn more about different assertions, you should mouse over them. Some of them are borrowed from other older testing libraries, and they're just really good because there's a lot of different recipes, let's say, that you could use to get a certain element. However, if you are using iframes, Cypress is probably not the best solution for you. There are some workarounds, but they're maintained, I think, by just like one or two people, not by the whole Cypress team. You can also create snapshots with Cypress. I didn't practice this ahead of time, so I don't know where my screenshot might be saved. And it's definitely something that you'll see in end-to-end development. But I think something happened there. I'm not really sure where it would have been saved. I thought it might end up in my downloads, but no, and that's okay. Sometimes you just try things out. Okay, I'm going to show you one more thing, which is specifically how to intercept a request that you're making from your component. And the reason why we couldn't do that on the sign-up form is because the request actually happens on the app instead. So I've set this up so that I can't mess up my imports. So imports came ready at the top of the page, and I'll make a new describe block. So we'll say that this describes our sign-up form with API interaction. It's the best I can do. Okay. Then I have my arrow function. And then inside, I'll have an if block. And we'll say that this submits the form and displays success pop-up on successful sign up. I'll just say displays pop-up on successful sign up because it doesn't do it any other time. And yeah, I think it reads like English, which is a pretty good metric for how you write your if blocks and your describe blocks. Okay, so we'll add this as well. Oh, need to close my string. There we go. And so the first thing I'm going to do is mount my app, my whole app, which isn't very big. So I don't think that this breaks any rules about component testing. But generally, I don't think you would mount your whole app. We're going to use sci.intercept. So sci.intercept here is going to be, or can be used both as a spy and a stub. And I'm going to show you both and kind of what happens. Don't know if you remember how they're different, but I have to set it up at the beginning of my test so that it can get called and waited for the response of later. So I'm going to make a post request to my server that is actually running still. And I'm going to alias this as sign up request. Okay. So now that I've done that, I can write the rest of my assertions. I can basically just make sure that I'm in the right place so that I'm on the sign up page. So this is to navigate to the sign up page. I'm then going to fill in my form. And then I'm going to submit my form before I wait for the result of my HTTP request. So sci.wait and then in strings at sign up request. And then its response dot status code dot should equal 200, which is a number. So you can see that I'm doing a lot of chaining of my assertions, and there's just things that happen in between these points, and that's why we say that Cypress yields its elements instead of returning them. Okay, so we're waiting on this sign up request. Let's check on our test to see how it's doing. Let's run it. Okay, great. So it waited for my sign up request, and the expectation is equal to what has been returned. Let's see what happens if I actually just like turn off my server. So I'm going to make this a little bit smaller, and I'm just going to kill my server. You can see my server down here, server running on 5,000. Cool. Okay, let's run my test again. Interesting. So my test has failed, and this time it's because I made it fail on purpose, not by accident. So we can see there's also a timeout after 4 seconds. That's just something that comes with sci-its because it didn't find my status code and it didn't actually find my response because there was an error. And I actually will take a look at the console for this one because I think it's kind of cool how you can see the response. So this feels so intuitive as a developer to open the console and take a look at what happened. So I can see there was no ability to connect. We were trying to do a post, and you can read more about specific things from Cypress here. But that's kind of what I'm interested as someone who's working on components and want to know if they can hit my API or not. So now that that's kind of taken care of, and we know that we can have a successful hit of the database, let's actually replace this function by using a stub instead and see how that kind of changes the behavior of sci.intercept. So here we're just providing it with, this is where you go to make this post request, please hit my server. When I stub this request, we're going to provide a body and a status code. And that is actually just providing that second argument is going to change this into a stub. So right here, I'm going to paste mostly commented out code. There we go. So now we have a status code of 200, a body with a message of you have successfully signed up. So you can already see that my test was like super fast and it ran as expected, but I can still make assertions on the stub and, check for all those different conditions just to make sure that I've built something correctly. Okay. I can also interact with my pop-up window, which is pretty cool. So sci.get, and I'm just going to paste this in because I don't want to mess it up. But yeah, I have a sci data of notification on my pop-up itself, and I'm checking for text this time. So you have successfully signed up. I'm checking for text because it's a success notification. I want to see a success message specifically. And then I can also close based on text and then check that the pop-up no longer exists. So I'll save this just so you can see it run. Nice. So we can see the overlay itself and the message inside. And then we can also dismiss it. And it happens in like the blink of an eye. But if you watch it obsessively, as you write your code. You really do see everything happen. So that is my entire demo. Let's just do a really quick review. What is Cypress? It's just one of the few testing libraries that makes testing like a user easier. I'm not saying it's the best one, but I like it. It's really good at waiting and retrying, interacting with elements most of the time, but it also gives you superpowers to hit your database or observe functions or change functions. What is component testing? It's just a way to test our components without having to do everything that goes into E to E testing. I definitely couldn't have shown you that many things while talking about E to E testing and setting it up for the first time. How do we write good tests? We just test for the use cases that make sense to test for, and that's most of them. So the happy path and not so happy path, we should test like what we think a user would do. And how are we solving for overwhelm by using Cypress? Cypress has great developer experience and it's super easy to read their docs. I've really enjoyed doing this. Thank you so much. I know I haven't left a lot of time for questions, but hopefully we can still get to one or two. And please look at this slide that came with my slide deck. I think it's so funny. Thank you.
Thank you so much, Chelsea. This was such an insightful presentation. And I also love the fact that Cypress itself it can allow for like it allows for retries automatically. I found that so cool. Because sometimes many people have to set that up and it's not fun. So yeah, I found that really cool. Did anybody have any questions for Chelsea in terms of Cypress?
Oh, Mimi asked, so the automate testing processes mean we download Cypress in our JS or TS app or JS/TS app, and then we write test cases for it. But can we, or how can we automate this in the pipeline? I can't really go into that today. I'm sure there's a hook for Cypress EDE for your pipeline, but these are just local tests for people who are implementing components. That's kind of what we talked about today. But there's so much out there in the Cypress docs, and they're really good docs. So I would encourage you to take a look into them. Danny says, so the more specific of what you're testing, the better. From the chart I had, yes, that is generally considered the best way to do it if you're being a little bit more specific about the function of what you're testing, even when you're setting that SciData attribute, you're making sure that other developers can see that like this is used in some of your tests. So that element is being used in tests, is being tested on, and that your tests rely on the functionality. So there's not a lot of surprises if a test fails and you touch something and it has a SciData attribute. And you can definitely write other types of tests, but again, like having to rely on certain tests or certain text rather, or certain styling is fairly brittle. What is the reason to use Cypress over Playwright, Selenium, PyTest? Because it's fun. Um, that's mostly my reason. It's fun, it's easy to do. I learned so much about Cypress just preparing to do this talk, and I had a really good time. I said to Nanzo at one point, like, I know I'm about to talk in front of people I don't know, but this is almost fun. And that's truly because Cypress makes it fun and it makes it really easy. They have lots of different like mini courses to teach you how to use Cypress. And as your first testing library, that's going to make it easy for junior developers and for senior developers, even just to be able to talk about testing so everybody can be involved. Whereas I think just taking a look very like shallowly at how Playwright has written their docs, it's not easy for a first-time developer to figure out, how to test, how to set their tests up, what to test. So that's one thing to say about it. Selenium also is pretty different than Cypress, and Cypress is using a real browser. So I think that is a big selling point as well. And you can do so many things that you would do in the real browser through Cypress. How does Cypress support API testing? Well, that's a great question. I'll have to get back to you, Amanda. But that is a really, really good question. And you can also, have your API tests specifically, on your server, but then have fixtures that are generated that you can use in Cypress. I've never seen anyone do that in real life, but if those are generated fixtures and those fixtures are updated automatically with every change to your API, then you'll have like more up-to-date fixtures, which can give you more reliable tests. Oh, Curtis has asked, what are the job prospects? I guess Cypress is used by like a lot of big brand name companies, and those same brand name companies, aren't beholden to one type of testing environment or one type of testing library. So I think it's just another great thing to have on hand, and it can get you started in learning more about just talking about testing and how to test, and that can be really important when getting hired. George, do we have time for this last question?
We'll take one more question and then we'll wrap up.
Okay, Amanda says, are there any performance considerations when running a large number of tests in Cypress, like for optimizing speed? Maybe. Yes. So, like I was talking about before, stubbing your requests, if you're going to um, make requests in your component test, will be a lot faster. On average, they're like 20 milliseconds, and that's a lot faster than hitting a real server that has to be running with a SPY request. And you can kind of transition from like we did before with SPY.intercept from a SPY type of function to a stub once you know the ideal return for your happy path situation. Um, yeah, great questions. Thank you so much. I really enjoyed this. And thanks, not so.
Thank you so much, Chelsea. This was so great. And before you go, I'm just gonna be reposting all the links to Tech Tank. If this is your first time joining us, then welcome. Here at Tech Tank, we really want to create an inclusive space for anyone in tech, really, to collaborate and make meaningful connections. We host a lot of networking sessions, social events, virtual discussions like these, mentorships, and more. For more information, please head over to our website at techtankto.com and feel free to join our awesome community. That's all we have for tonight, folks. We'll catch you in the next one. Have a great night. Bye, everyone.